to talk about Lewis dot structures for compounds. The first one's for ionic bonds. There are 3 steps to this that you'll need to write down in your notes. Make sure you write small enough to get all 3 steps in your notes. First step, the chemical symbol for the element is surrounded by the number of valence electrons present in the ion. This is very important. It's valence electrons in the ion. So let's look at our example of lithium and fluorine. Lithium is right here in group 1, which means it has 1 valence shell electron. And fluorine is right here in group 17, which means it has 7 valence shell electrons. Now lithium wants to look like a noble gas, so it can lose 1 electron and look like helium right here, or it can gain 7 electrons and look like neon. It's much easier for lithium to lose an electron, so that's what it's going to do. It's going to lose it. Now fluorine has 7 valence shell electrons. It can lose all 7 and look like helium, or it can gain 1 and look like neon. It's much easier for fluorine to gain 1 electron, so fluorine will be more than happy to take that 1 electron from lithium. Now when that happens, I'm going to write it up here. Lithium now has no valence shell electrons, and fluorine now has 8. 1, 2, 3, 4, 5, 6, 7, 8. When it becomes an ion, because lithium loses its electron, it now becomes an ion with a plus charge, and fluorine gains an electron, so it becomes an ion with a negative charge. Step 2. The whole structure is then placed within square brackets with a superscript to indicate the charge. So lithium now has no valence shell electrons. Here are our brackets, and our superscript right here is a charge of +1. Fluorine, don't forget to write your valence electrons. It has 7. And it has a superscript of a -1 because it has a -1 charge. The third step is the overall charge on the compound must equal 0. So lithium has a +1 charge, and fluorine has a -1 charge. So 1 minus 1 equals 0. So we're good there. Now let's do a second example. Sodium and chlorine. Sodium is right here. It has 1 valence shell electron. And chlorine is right here. It has 7 valence shell electrons. When it becomes an ion, sodium is going to give its electron to chlorine. So sodium will look like an Na, and it will become a positive charge. And chlorine will now have 7 valence shell electrons plus 1 plus sodium, so it has 8 valence shell electrons, and it has a negative charge. Sodium has no valence shell electrons because it's given it to chlorine. Third example, magnesium and oxygen. Magnesium's right here. It has 2 valence shell electrons. And oxygen is right here. It has 6 valence shell electrons. Magnesium is going to give each of its electrons to oxygen, and it will become an ion with no valence shell electrons around it. So I will just put brackets with no dots, and it now becomes a +2 charge. Oxygen now has 8 valence shell electrons around it, and it has a -2 charge because it has taken magnesium's 2. Now let's make sure our charges are equal. 2 minus 2, this is a positive, is 0, so we're good. All right, magnesium and chlorine. Again, magnesium has 2 valence shell electrons. When it becomes an ion, it is going to lose both of them, and it will have no valence shell electrons. So we will put a +2. If you notice on the last one, I put 2+, and on this one I'm putting +2. You can go either way, it doesn't matter. Okay, chlorine has 7 valence shell electrons. When it becomes an ion, it gains an extra electron, so we are going to put chlorine 1, 2, 3, 4, 5, 6, 7, 8. And that is a -1 charge. Magnesium gives 1 of its electrons to chlorine, so I'm going to put that as an X. Now magnesium has another electron to give away, so we need another chlorine to take it. In order to do that, I'm going to put that chlorine over here. Now the reason I put the chlorine over here is because opposite charges attract. And a negative charge and a positive charge should be next to each other, positive and negative. If I put this chlorine over here, it would be a negative next to a negative, and that would be incorrect because like charges do not attract, they repel. Okay guys, I would like for you to pause the video and do the next 6 practice problems on your own and then come back and check your answers. Okay, check your answers. What I want you to pay close attention to are the charges and whether or not they add all up to 0. So if we have here a -2 plus a 3 equals +1. Well, here, just let me write this down. -2 plus 3 minus 2 plus 3 minus 2. All of that does equal 0. Go ahead and check your answers here as well. Okay, now let's talk about covalent bonds. There are 3 steps in determining the Lewis dot structures for covalent bonds, so make sure you leave enough room to write all 3 steps. First step is you write the Lewis structure for each atom in the molecule. And our example is chlorine. So we know chlorine's right here. It has 7 valence shell electrons. There's 1. We're writing it for each atom. And there's the other chlorine. Next step, you arrange the atoms to form a skeleton structure for the molecule. If carbon's present, then carbon's the central atom. Otherwise, it's usually the first atom written. In this case, it's chlorine. Except for hydrogen, it's never the center, whether it's in the front or not. Okay, so right here is the skeleton structure. Okay, third step is you rearrange the valence electrons around each atom. So if we have hydrogen, each atom shares a pair of electrons. We don't have hydrogen, so we're not going to look at this rule yet. Or that each other nonmetal has 8 valence electrons, which is 8 shared and unshared, a total of 8. So if we look right here, this chlorine, let me just go ahead and write it. It has 8 valence shell electrons, 2, 4, 6, and then 8 right here. And the same thing with this chlorine atom. It has 2, 4, 6, and 8. So right here is our bond. Okay, so what we're going to do, wherever there's a shared pair, we're going to draw a line. We're going to draw a line. So this would look like this. This is the Lewis dot structure for the covalent compound chlorine. This is a green gas, by the way. You've got 6 pairs of electrons that are not shared on this chlorine, and 6 pairs of electrons that are not shared on this chlorine, and 1 pair that are shared between the 2. All right, now let's do CH4. First step, we are going to write the Lewis structure for each atom. So carbon is right here. It has 4 valence shell electrons. Hydrogen is right here. It has 1 valence shell electron, and there are 4 hydrogens. Second step is to arrange a skeleton structure where the central atom is in the middle. Now the central atom's always carbon if carbon is present. So carbon is our central atom. Next step, we connect our elements so that hydrogen each has one shared pair of electrons. And lastly, we take our shared pairs and we connect them with a line. This is what our Lewis dot structure looks like for methane. First step, our central atom is nitrogen. So I am going to go ahead and write the valence shell electrons for that. It is in group 15, which means it has 5 valence shell electrons. So 1, 2, 3, 4, 5. We have hydrogen. There were 3 of them, and each hydrogen has 1 valence shell electron. So we are going to pair those up so that it is sharing a pair of electrons with nitrogen. And last, we are going to connect each of our pairs that are shared and bonded with a white line. This pair of electrons right up here on the above nitrogen is not shared with any other atom. So that means that it is a non-bonding pair and we have no white line on it. So right here is the correct Lewis dot structure for NH3. Sulfur will be our central atom, and it is in, here's sulfur, it's in group 16, which means it has 6 valence shell electrons. So I'm going to go ahead and write all of 6 valence shell electrons on here. Hydrogen's in group 1, has 1 valence shell electron, and there are 2 of them. I'm going to write them so that each one has a shared pair. My last step is to combine or connect the shared pairs with a line to show that they are a shared pair, and here's our Lewis dot structure for H2S. Now I would like for you to go and practice the 6 problems and then check your answers. I'd like for you to go ahead and check your answers. These are some tougher ones. If you notice, there's some double bonds here, and nitrogen has a triple bond.